Hello everyone, micrometer screw gauge is a very common measuring instrument that using vernier principle. Today I am going to discuss about main parts, least count, zero errors, and getting readings etc. Parts of a micrometer screw gauge. Frame. Anvil. Spindle. Anvil is a stationary part and spindle is moving. These parts used to detain the measuring object. Barrel or sleeve. This is a stationary part. Linear main scale is on this and rotating parts move on it. Thimble. Vernier scale or circular scale is attached to that. Ratchet. If you want to move the vernier scale, must use this part. Then you can cleanly fit an item between anvil and spindle. When item is fixed, there will appear a special sound. Lock. Use this part to lock the vernier scale. Spindle, ratchet and thimble attached to each other and no relative motion among each other. But ratchet can rotate relatively. Least count. If you want to find the least count of a micrometer, you must remember this equation. It is least count equals main scale screw pitch into number of vernier parts. Main scale screw pitch means how many distance thimble move horizontally in a 360 degrees rotation of vernier scale. It usually equals to the smallest main scale partition. Let's going through this example. First 5 mm mark divided to 10 partitions. Then smallest main scale partition equals to 0.5 mm. Number of vernier parts. In the vernier scale after 45th mark you can see 0. So that there are 50 vernier scale partitions in the gauge. Now you have these two values. From the equation you can calculate the least count. This is the mathematical way of calculate the least count. But in the gauge, you can see the least count and 0 to 25 mark. It is the range of the micrometer. Before moving to zeroth error, consider about the right-hand screw law. Because it gives us the directions of motion. Micrometer screw gauge has moving components and vernier scale is attached to that. The rotating principle is screw mechanism. So that we use right-hand screw law to find the moving direction. You can bring your 4 fingers to ratchet rotating direction and you can get the thimble linear moving direction from your thumb finger. Positive zero error. Before use the instrument we must get it to the zeroth position. When anvil and spindle touching each other, vernier 0 must coincide with main scale 0. But in this case the circular vernier scale 0 cannot rotate to the point of main scale 0. When we rotate vernier scale to left side towards anvil, vernier 0 stops before touching the main scale 0. You can use the right-hand law to find the moving directions. This is positive zero error. It means when anvil and spindle are touching, micrometer gauge displays a positive value. If we get a reading from this kind of gauge, we must reduce the error to get the real value. To get the error you must get the coincide vernier value and multiply it from the least count. There are some reasons for this issue. The main reason is smear something between anvil and spindle. As examples: corrosion, rust and dirt rubbish. Other reason is dilatation due to high temperature. Negative zero error. In this case the circular vernier scale 0 rotate more than the coincide position with main scale 0. When we rotate vernier scale to left side towards anvil, vernier 0 stops after touching the main scale 0. This is negative zero error. It means when anvil and spindle are touching, micrometer gauge displays a negative value. If we get a reading from this kind of gauge, we must add the error to get the real value. There are some reasons for this issue. The main reason is wear and tear of anvil and spindle. Other reason is contraction or compression due to low temperature. This is a micrometer that haven't any zero error. Hear the special sound of the ratchet when anvil and spindle coincide. When we move, the dynamic part of micrometer must rotate the ratchet, because measuring item ideally fix from the ratchet. If we use the thimble, it is harmful for the gauge and measuring item. This is the main reason to appear a negative zero error. Now we are moving to the end of the video and most important part. It is reading the micrometer and correcting the error. There are few steps to get the real value of the measurement. First of all, you must find the least count of the micrometer. Second step is finding the zero error. Third one is getting the reading and get the ideal value from correction. This is the equation. There are two readings, main scale reading and vernier scale reading. You must get the last appearing part as the main scale reading. Vernier scale reading equals to coincide vernier part multiply from the least count. Finally, add or subtract the zero error according to the type of error. If error is positive, subtract the error. If error is negative, add the error to the reading value. This is a real-world example. You can see the zero error, reading, and correction. This is a real-world example. You can see the zero error, reading, and correction. You can see the least count is 0.01 millimeters and calculate the zero error. It is minus 0.01 millimeters. Now we can get the reading. Main scale value. After 10th mark you can see the 11, 12, 13 values. And finally you can see the 13.5 mark. It means main scale reading is 13.5 millimeters. You can see the 27th vernier scale part coincide with the horizontal line. So that vernier scale value is 0.27 millimeters. This is the equation. The error is negative, so we must add this error to the reading. The actual measurement is 13.78 millimeters. You have an example question. Try this.